Your AI agent is brilliant, but it doesn't know what happened today. It hasn't seen what's in your company documents. It hasn't read the support ticket your customer just opened. That's the problem RAG solves. In 5 minutes, what RAG actually is, why every serious agent needs it, and how to build one. Let's start with why this matters in the first place. Large language models have 3 blind spots that affect every real application. First, they're frozen in time. The model stopped learning at its training cutoff date. So anything that happened after that, yesterday's product launch, last week's news, this morning's meeting notes, the model has no idea about. To the model, those things simply don't exist. Second, they've never seen your private data. Your company wiki, your customer tickets, your internal documentation, your codebase, your pricing, your policies. None of it. The model knows the public internet up to its cutoff, and that's it. Third, they hallucinate. When asked something they don't know, models often invent answers. Confidently. Fluently. Wrongly. They don't always say I don't know, they fill in the gap with something that sounds plausible. Each of these alone is a problem. Together, they make LLMs unreliable as the brain of an agent that needs to know real, current, specific things. Enter RAG, Retrieval-Augmented Generation. The idea is simple. Don't rely on the model's frozen brain. Look up the relevant facts first, then hand them to the model along with the question. Now the model is answering based on real information, not guesses. There are 4 steps to make RAG work. Step 1, Embeddings. We take every chunk of text we care about, every paragraph from your wiki, every support article, every relevant document, and convert each one into a vector. A vector is just a long list of numbers, often hundreds or thousands of them. The magic of embeddings is that texts with similar meaning end up close together in this high-dimensional space. The phrase "cancel my subscription" lands near "end my account." A question about pricing lands near pricing-related content. Meaning becomes geometry. Step 2, store all these vectors in a vector database. Pinecone, Weaviate, Vector, Chroma, they all do the same job. Store millions of vectors, find the closest ones to a query in milliseconds. Pick whichever fits your stack. Step 3, when a user asks a question, embed the question too. Now ask the database, find me the top k vectors closest to this query. Usually 3 to 10. These are the most relevant chunks of context for whatever was just asked. Step 4, stuff those retrieved chunks into the prompt. The model now sees the user's question plus the relevant context. It writes an answer grounded in your actual data, not in its imagination. Putting it all together end to end. User asks a question. We embed the question. We search the vector database for similar chunks. We get the top matches. We stuff them into the prompt with the question. We hand it to the model. We get a grounded answer back. That's the entire RAG pipeline. Maybe 100 lines of code from end to end. It's how you turn an LLM that knows nothing about your world into an agent that answers from your wiki, your tickets, your documents, your data. A few things that trip people up in production. How you chunk your documents matters more than people expect. Too small and you lose context. Too big and you waste tokens. A reasonable starting point is around 500 tokens per chunk with some overlap between adjacent chunks. Don't trust top K retrieval blindly. Add a re-ranker. A re-ranker is a smaller, faster model that takes the top 50 candidates and rescores them against the query. Massive precision improvement for relatively little extra latency. Use hybrid search. Vector search alone misses exact matches, product SKUs, version numbers, specific names. Combine vectors with classic keyword search like BM25, then re-rank the union. And critically, evaluate retrieval quality separately from generation quality. When users complain about bad answers, the cause is almost always bad retrieval. The model can't fix what it didn't receive. That's RAG. Retrieve. Augment. Generate.